once I can get this one running again. Kita akan start the assessment. So this bukan, it's like it's not a graded assessment. So just nak tengok sama ada how well do you understand chapter 2.
Yang tak dapat join quizzes tu tak apa ke sir?
Tak apa, just share screen, sebelum tengok screen lah. So this is the new link. Saya akan share. Ataupun kamu boleh just go to join quiz. Yeah, so please join this quiz. Just now was just for fun. Ini quiz about volumetric analysis, which is chapter 2. So wait for everybody to join lah. Kita akan mula. And by the way, also pagi tadi saya dapat update about your lab class. So some of you have opted to balik college, datang campus. Kamu 35 36. I was told you are going to come back separately kan? 35 datang dulu, 36 datang dulu. So kamu akan start your lab class macam seminggu ke 2 minggu earlier than cohort 35. Okay, so kita akan buat separately. So for now, I'm going to use the Friday class for lecture class, tapi just for 2 hours sajalah. Okay, because our lecture class sekarang schedule for 4 hours, macam hari ni sepatutnya pukul 2 sampai pukul 6 kan, 2 slots. So sekarang because kamu dah ada option untuk buat physical lab class, saya akan ambil kelas pada hari Jumaat tu for 2 hours. So hari ni kita tak akan go over 4 o'clock lah. Okay. And also, kalau saya tak pasti kalau kamu dah diberitahu belum, bagi yang datang ke campus, the lab class kamu buat secara face to face. Tapi bagi yang tak boleh datang, kamu masih lagi perlu attend the class. Saya akan live stream the class. So you will have to join. Okay, so 40 orang dah join, so kita mula dulu. Nak join kemudian boleh. Also standby a calculator because kamu kena buat titration calculation later. Alright, so number 1, to prepare a solution of accurately known volume, use the what? The options kat sini dia ada bagi 4 pilihan. So choose the one yang kita boleh guna untuk accurately measure a value. Measure a volume. Sorry, bukan to measure, to prepare a solution. My bad. Okay, jawapan betul ke ni, kenapa kosong, tak ada orang sempat jawab ke? So jawapan yang betul adalah volumetric flux, mesti sebab bandwidth banyak sangat sebab ramai participant, so internet saya slow tak detect. So jawapan yang betul adalah volumetric flux. Okay, so volumetric flux is the glassware that we use untuk prepare standard solutions. And standard solutions are solutions that we know the concentration of. Okay, so how, if you want to prepare a solution, and you want to know the exact volume and the exact concentration of that solution, we use volumetric flask. All the others ni kita guna untuk mixed solutions, also mixed solutions, beaker, conical flask, mixed solutions, measuring cylinder, kita measure volume secara kasar, roughly, not accurately. Next one. To deliver a fixed accurate volume of a solution, use a what? Four options here: pipette, burette, dropper, or beaker. Deliver in this case, kamu nak transfer from one glassware into another. Tapi we want to do it in accurate measured volume. The answer is pipette. Let me refresh. Saya tak nampak ini. Kamu boleh jawab tak? Okay, saya syok seorang. So jawapan yang betul for that question just now is pipette. Pipette is the glassware that we use. Yang last week, one of you corrected me. I forgot the name already. Ada volumetric pipette, the ones yang just the glassware hanyalah straightforward. Satu lagi apa benda? Forgot the name. Zero types of pipette. You endorse me. Graduated and no, not this one. Sad, you give me a minute. Pipette with bulge. I will get this. Still known as volumetric pipette. I forgot the name. Okay, this is a pipette. Dia ada dua jenis. Satu yang just straight, clean, macam ni, graduated. Ataupun the other ones are like this. Dia ada bulge in the middle, ada written exact volume. So for each sizes, they measure different amount of volume. So kalau nak measure 10 milliliter of volume, you use this pipette saja, 10 milliliter. Kalau nak measure 50 milliliter, use this one. What this one is called? Something pipette. Volumetric pipette is the one like this. Just straight, tak ada bulge in the middle. Never mind, this is really late. Okay, next question. Saya tak ingat sebab baru minggu lepas saya tahu nama lain untuk benda tu. Sebelum ni saya pakai volumetric pipette saja. Syringo form. To deliver various volumes of a solution. Okay, time's up. Jawapan yang betul adalah burette. Okay, so burette is kita tak guna untuk measure a volume from one beaker, from one glassware into another. So the use of a burette adalah specific untuk titration sahaja. And we use to measure the amount of volume used in titration. So that's what I kata kat sini, to deliver various volumes of a solution accurately. The specific as to a solution, because in titration we use the same solution, but we use it multiple times because we are titrating duplicates. Okay, duplicate meaning kita titrate the same solution but 3 or 4 times. So that's why they highlight the word various kat situ. A standard solution is a solution with accurately known concentration. True or false? So, let me stop myself because saya lagi tak jawapan. You have 10 seconds. Alright, so it is true. So any solution that you know the concentration of, that you have accurately determined the concentration of, bahan tu, that solution can be a standard solution. Okay? Tetapi not necessarily dia mestilah bahan yang mematuhi the criteria, iaitu high purity, stabil, and satu lagi tapi most important ones adalah high purity and stability. The other two adalah not hygroscopic, and I forgot the other one. Can I refer back to my lecture notes?
High molar mass.
Sorry?
High molar mass. Molar mass.
Thank you. High molar mass. And high molar mass and not hygroscopic, dia akan menyumbang kepada stability. That's why I said stability and high purity is the main thing lah. Okay, thank you, Shafika. Next one, the point in an acid-alkali titration at which the reactants just react completely with each other is called the what point? Ada dua option sahaja and 4 more seconds. Okay, so the answer is equivalence point. Okay, so kamu kena tengok betul-betul dia jawapan dia bukan endpoint, because endpoint and equivalence point, walaupun it happens at the same time, it occurs at the same time, but they both mean essentially different things. Equivalent point, it means dia menyatakan ya bahawa kedua-dua bahan yang bertindak balas sudah bertindak balas dengan sepenuhnya, sudah digunakan dengan sepenuhnya untuk menghasilkan bahan hasil. Okay, all the reactants are all used up to produce the product. That is equivalence point. Satu titik di mana kedua-dua bahan yang bertindak balas sudah habis digunakan. Endpoint is just a point in satu titik di mana kita stop titrating. Okay, so what is the point? Color change. So bila pertukaran warna berlaku in our solution, in our sample solution, kita stop titrating. That is the endpoint. Okay, that is the definition of endpoint and the equivalence point. So walaupun dia berlaku serentak, tapi they are different things. Okay, so most of you got it right, tapi yang salah ni 13 ni, so make sure you know perbezaan antara kedua-dua benda ni. Blank is a suitable indicator for the titration of a strong acid and a weak alkali. Options yang ada kat sini, metal orange, phenolphthalein, litmus solution, and universal indicator. So bagi yang tak boleh join, kamu just pay attention to the screen lah. Okay. Alright, so end question. The right answer adalah metal red. Metal orange, sorry. Okay, remember dalam lecture note saya ada buat apa nama that table yang recommend which indicator is best. Kita tak boleh guna phenolphthalein. Okay, because it wouldn't be efficient indicating the endpoint. Next question. Blank is a suitable indicator for the titration of a weak acid. Is this the same one? Not sure. We wait, tengok. Jadi weak base and strong weak alkali terbalik tukar the strength. Okay, so which one is best? The option sama macam tadi, phenolphthalein, methyl orange. Okay, so the right answer is phenolphthalein. Also ada dalam apa nama lecture note saya tu. Okay, dia tunjuk ada table, saya tunjuk weak acid dengan strong base. Strong base and weak acid. So phenolphthalein is a good indicator kalau kita nak titrate a weak acid dengan strong alkali, strong base. During titration, the endpoint and the equivalent point always occur at the same time. So, ini macam soalan bocor, because tadi saya dah ulang 2-3 kali. True or false are the options. So, I end this now, because the answer is true. The endpoint and the equivalence point always occur at the same time. The endpoint is used to indicate the equivalence point. No, I think, sorry, this is a typo. The answer is true. It always happens at the same time. Okay, so saya tak tahu kamu sempat kira ke tak. You have 30 seconds and you calculate this. $20 centimeter cubic or 1 mole require the same number of moles for complete neutralization. Oh, okay. So not really a calculation question. That's why you woke up. Okay, so the answer is true. Kat sini, apa nama, kamu kena tengok dia punya. So let me read the question again. 20 for complete neutralization. Wait a minute. I need to understand. 20 centimeter cubic of 1 mole and 10 centimeter cubic of 1 mole equate the same number of. Saya tak nampak pula NaOH ni tadi, so I thought dia tengah titrate sulfuric acid dengan acetic acid. Now I'm confused. Tapi ramai jawab betul. Why do you jawab betul? Boleh tak explain pada saya? I honestly tak tahu saya faham ke tak faham soalan ni. 20 centimeter cubic. Give me a minute. 20 centimeter cubic.
Sir,
Yes.
Nanti nak tanya pasal yang Fino tadi tu.
Sorry?
Tak apa, sekira dulu.
Terima kasih kerana memahami. Now my quizzes are hang. The answer is true or false. 20 centimeter cubic of 1 mole. 20 centimeter cubic of 1 mole and 10 centimeter cubic of 1 mole require the same number of moles of NaOH for complete neutralization. What? I don't understand. Kamu pun tak tahu macam kamu jawab true ni, kamu hentam ke kamu tahu, kamu faham the question? I don't understand the question. Sorry. No, tak. I don't understand this. Okay, next question. In a titration experiment, a pipette is washed with distilled water and the solution is contained. Kamu tengok dulu soalan, sorry lah saya tak check dulu dia questions. Terabuk grammar. So basically dalam soalan ni dia tanya, we wash the pipette with distilled water and then kita rinse dengan the solution that we are going to use, that we are going to measure before kita actually guna. So the answer, dia tanya kat sini true or false kot. True or false. Okay, so the answer is true. The best practice of using a pipette adalah kita rinse dulu dengan distilled water. And then before kita actually use to extract the volume that we want of a solution that we want, kita rinse dulu. Okay, katakanlah we have, kita nak measure 10 ml of hydrochloric acid. So kita gunalah pipette. So before we use the pipette, kita rinse dulu dengan H2O. Yes. Okay. And after we rinse with H2O, kita rinse dengan HCl. So bila dah rinse, barulah kita extract 10 ml of HCl. So the purpose we do this adalah untuk cuci. So kita nak make sure our pipette tu clean from other impurities, because kalau kita kerja dalam lab, we are not the only one who are using the glassware, the instruments. Orang lain pernah guna dah sebelum ni. So this pipette could have some residue of some other chemical solutions yang orang lain pernah guna. Okay, so kita nak make sure that thing is betul-betul bersih. The best way, the best practice is kita akan buat this. 2 kali cuci, rinse dengan H2O and rinse dengan the solutions that we want to measure. Okay, so the answer for that question just now is true. Soalan seterusnya. In a titration experiment, a conical flask is washed with distilled water and the solution is to contain before use. So sama juga macam tadi, the answer is true. Basically all glassware, all instruments dalam lab, best practice is kita rinse 2 kali macam ni. Rinse dengan distilled water and then rinse with the solutions that we are going to use it on. Okay, next question. Saya dah jawab sementara kita tunggu that question to finish just now. Next question, what volume of water is required to dilute? Okay, this is the kind of question yang saya thought akan ada. So kamu kena calculate the amount of volume. So the tip is guna titration equation M1 V1 equals to M2 V2. Identify which is M1, V1, M2, and V2. Okay, so 50 jawab ramai. So jawapan yang betul is 24. So half of you got it right, the other half got it wrong. So let's do it together. Okay, so nak jawab soalan ni, saya dah bagi tip tadi, guna M1 V1 equals to M2 V2. So M1 V1 equals to M2. My tip for you, for students, is always write down whatever he gave you. So kat sini dia bagi tahu volume 120 and 10 mole dm per dm cubic adalah the concentration, which is the molarity lah. So kita tulis kat sini M1 equals to 120 centimeter cubic. Oh my bad, silap. M1 is 10, dah silap kan? 10 and 120, yes. M1 is 10 mole per dm. Volume 1 is 120 cm centimeter cubic. M2 and V2 are respectively dia bagi M2 saja, so dia sudah cari volume. Okay, so 2 mole decimeter cubic. 2 mole decimeter cubic. And also, kalau macam kamu tak masih lagi fasih with the units, so remember the definition of molarity adalah the number of moles in volume, okay, per liter solution. So this unit ni menunjukkan the amount of mole dalam volume. dm cubic ni equals to liter. Another unit untuk mengukur volume. Okay, so this is the things that the data that we have from the problems and problem statement from the questions. So dia suruh kita cari volume. So just solve for V2 lah sebab kita tak tahu V2 ni apa. So from this equation, just rearrange. V2 equals to M1 V1 divided by M2. So M1 is 10 mole per dm cubic, darab dengan V1 which is 120 centimeter cubic and divide by 2 mole per decimeter cubic. So this is the answer lah. So most of you got it right. Half of you got it right. Okay, not that most lah. Kenapa boleh tersalah kat sini? Sebab 19 orang jawab. Yakin dia 600? 100 bagi 2. 120 bagi 2 is 1200 bagi 2 is 600. So kenapa 480 kat sini? Oh, stress. Why many of you jawab 480 and sini the set betul? We're going to dilute 1 to oh. So this is correct. 600 is the answer. Okay, sorry, sini ada silap lagi, error. Kalau this is a graded assessment, this will be a bonus question. Tapi saya tak faham kenapa ramai jawab 480. 120 times 10 is 1200. 1200 bagi 2 is 600. If you cancel out the unit, volume kat sini adalah mole pun cancel. So centimeter cubic. So 600 centimeter cubic. 600 milliliter is the answer. Okay, option number 3 is the correct answer. Ada anybody nak explain kenapa macam mana boleh dapat 480? So that I can understand kat mana kamu Kamu salah?
Sir,
Ya.
tak perlu tukar sentimeter cube kepada tak perlu tukar unit ke sir?
Tak perlu tukar unit. Okay, so dalam apa nama, macam ni, kalau macam mana nak tahu kalau kamu perlu tukar unit ataupun tidak. So if you have a problem like this, kamu tengok all the parameters. M1 dalam mole per decimeter cubic. Ini pun dalam mole per decimeter cubic. Ini dalam sentimeter cubic. Ini tak diberikan. So kalau kita tengok all are the same, we don't need to change. Unless kalau kat sini dia bagi, dia tak bagi dalam 2 mole decimeter cubic, tapi dia bagi dalam 2 mole, dalam molality is kilogram per kilogram. Oh, sorry, per kilogram, negatif 1. So kalau jadi macam ni, you have to convert this molality to molarity. Kamu kena convert from kilogram kepada mole decimeter cubic. Kena samakan dia, both counterpart. Kalau kita tengok dalam equation, ada dua parameter kat sini, M1, M2, V1 dan V2. So both of them, molarity dengan molarity mesti unit yang sama. Volume dengan volume mesti unit yang sama. Kalau dia berbeza, you have to convert one of them so that they would be the same. Okay, so kalau jumpa problems like that, you know you have to do conversion. Tapi kalau dua-dua sama macam ni, tak perlulah. Okay, so kamu buat conversion ke, that's why kamu dapat 480?
Sir tengah kira ke sir?
Apa kamu, saya tak dengar.
Tadi saya tak nampak sekira.
Baik. Oh, my bad. Saya share tab, saya tak share screen. Sorry.
Share ni.
Ya, saya stop ni.
Calculation.
Sebab saya kalau saya share screen, dia jadi lag sikit. So saya share just the tab. Never mind, sekarang saya share the ni. Alah, saya goreng seorang-seorang tadi. Okay, so this is the thing yang saya conteng. Okay. So, the first thing yang saya cakap tadi kena buat, you write down the equation, which is this one lah. And then tulis apa yang dia bagi kepada kita, M1, V1, M2 dan V2. V2 kita tak tahu, dia suruh cari. So, kita susunlah this equation so that we can find V2. So, jadilah V2 here equals to M1 V1 divided by M2. So, M1 is 10, so that's why sini saya tulis 10. Darab dengan 120 divide by 2. So 120 times 10 is 1200. Bagi dengan 2 dapatlah 600 cm cubic. So that's how we know the answer is 600 cm cubic. So that's why kat sini, dalam this question, saya nak tahulah kenapa macam ramai sangat jawab 480. So kalau kamu macam tak sure ataupun kamu macam malu nak beritahu, just know this is the jalan kerja. This is how we do the calculation. Oops. Okay, clear? So dekat dalam ni, quizzes ni dah salah lah. Okay, 400 cm cubic is wrong. Okay, next one. Okay, so what volume? Okay, ini pun kamu guna M1 V1 equals to M2 V2. So let me do it also so that I know the question, the person yang buat this quizzes set the answer correctly. 5 mole oh, dia nak dilute the solution. Okay, so the same. Go to this one. Okay, so we are still using M1 V1 equals to M2 V2. M1 being 5 mole decimeter cubic. V1 disuruh kita cari what volume. M2 is 0.40 mole decimeter cubic. V2 is 250. Okay, so tadi to answer your question, Bavindra tanya bila masa kita nak convert ataupun tidak. So once again saya repeat kat sini, kamu tengok all the parameters of molarity, concentration and volume. So kalau kamu tengok molarity here, M1 and M2 both of them are in the same unit, mole per dm cubic. Ini pun mole per dm cubic. So no need to do any conversion. Okay? Unless kalau macam untuk M2 dia bagi dalam molality, mole per kilogram. So kalau dia bagi this unit dalam 0.4 mole per kilogram, you have to convert this into mole per dm cubic. Okay? So tengok dulu the units of all the parameters sama. Kalau sama tak perlu perform conversion of units. Dah habis kan rasanya? Okay, so the answer is 20 cm cubic. Tengok kat sini betul ataupun tidak. Kita nak cari V1. So V1 equals to M2 V2 divided by M1. So M2 is 0.40 mole per dm cubic. So when you buat jalan kerja, always write the unit. Okay, the reason is in the end nanti kamu akan tahu what unit will be left. Volume 2 250 cm cubic bagi dengan M1 which is 5 mole dm cubic. Kamu tengok unit untuk ni dan unit ini sama. So di dalam function bagi, so we can cancel it out. The same number bagi dengan same number, kamu boleh cancel it out, dapat satu. So this is the same logic lah. So cancel each other out. So the remaining unit adalah centimeter cubic, which is the unit untuk volume. Okay, so 250 darab 0.4. Sini bagi sini dapat 50 0.4 darab dengan 50 cm cubic, which is 20 cm cubic. So this one betul. 20 correct? Yes. 44 of you. Okay, thank God. Tadi dia silap. Kita betul. Alright, so that is the jalan kerja lah. Okay, bagi yang salah, ada kat sini 9 orang salah and ada some of you yang tak boleh join. Bagi yang tak tahu, bagi yang tak tahu macam mana nak mula, this is it. Kamu start dengan the equation that you want to use. And then you write down what you get from the questions. Kat sini dia bagi molarity M1. M2 pun dia bagi. V2 dia bagi. And dia suruh kita cari volume. So you just rearrange to find V1 using the equation that we know what we want to use. Okay. Next question. Ada 2 more slides, 2 more questions, and then we take 5. Uh, 3.75 decimeter cubic of distilled water are added to kat sini dia bagi unit of volume different. So kamu kena be careful. What is the molarity of the diluted solution? This is volume. In case kamu tak tahu, sentimeter cubic bersamaan dengan mililiter. Decimeter cubic bersamaan dengan liter. 1 mililiter bersamaan dengan 1000 mililiter. So samalah kalau 1 centimeter cubic bersamaan dengan 1000. Terbalik, my bad. Rewind, jangan terhasut. 1 liter equals to 1000 milliliter. 1 decimeter cubic equals to 1000 centimeter. Okay, ini dia punya relationship lah antara liter, mililiter dan dm cubic dan cm cubic. So both, all of them can be used to measure volume. All are unit for volume. Okay, questions tadi dah habis belum? Belum lagi, 20 seconds. So dia tanya molarity, that means dia nak suruh kamu cari the concentration. 3.75 decimeter cubic of distilled water are added. What is the molarity? So dekat sini dia perform dilution. Dia tambah the volume of the solvent. So the concentration, sama macam kamu nak cairkan air yang terlalu manis. Suara saya is going away. So the answer is 0.2 mole per decimeter cubic. So how did we, kenapa ramai yang jawab salah? Masih sebab conversion of unit. So kat sini kamu kena convert the unit. Kat sini the volume dia bagi dalam decimeter cubic. Kat sini dia bagi dalam centimeter cubic. Okay, so it is kamu kena dia nak unit dalam decimeter cubic lah. Okay, tengok option kat sini semuanya dalam decimeter. So kamu kena convert this 250 to decimeter cubic. So how to convert? That's what saya bagi tadi. 1 liter sama dengan 1000 ml. So 1 decimeter cubic bersamaan dengan 1000 centimeter cubic. So dalam this question dia bagi 250 centimeter cubic. Kita kena convert this one to decimeter cubic, dm cubic. So how to do that? Kalau macam kamu tak fasih lagi, you write this one dulu. 1 dm cubic sama dengan 1000 centimeter cubic. So kamu ada 250 centimeter cubic. So kamu nak cari kat sini X, berapa X dm cubic ni? Kamu tak tahu. So my advice is kamu buat darab silang. So 1 dm cubic bahagi dengan 1000 centimeter cubic equals to X decimeter cubic divided by 250 centimeter cubic. And then carilah solve for X. Bawa 250 ni ke atas, darab benda. So X decimeter cubic equals to 250 centimeter cubic darab dengan 1 decimeter cubic divided by 1000 centimeter cubic. So kalau kamu buat macam ni, kamu akan nampak this one sama dengan this one cancel out. So tinggallah unit dm cubic. So 250 darab dengan 1 bahagi dengan 1000. So 1, 2, 3. 0.25 decimeter cubic. So this is the value that we use in the calculation of M1 V1 equals to M2 V2. Okay, so ini 0.25 darab dengan 3.20. 3.75. So this one is 3.75 dm equals to M2 is kat sini 3.2 mole decimeter cubic. 3.2 mole darab dengan 0.25. Sini kita nak cari M1. So solve for M1. 3.2 mole decimeter cubic darab dengan 0.25 decimeter cubic divided by 3.75 dm. So kalau buat macam ni, cancel out. Dan sini ada mole kan. Sini ada mole. So ini cancel. Ini cancel yang ini. So tinggallah unit volume. So M1. Oh, I was right. Okay, so cancel the volume unit. So yang tinggal adalah unit untuk concentration. So dapatlah jawapannya kat sini, which I believe is 0.2 mole per decimeter cube. Ya?
Jawapan dia 0.213.
Jalan kecil yang saya buat ni ke? 3.2. Okay, so obviously this person is wrong. Okay, because this is the jalan kerja. Okay, conversion pun macam ni. Kamu nak convert the unit pun macam ni. Okay, so the conversion of unit is like this. Sentimeter kubik dengan desimeter kubik kamu bahagikan dengan 1000, kamu akan dapat 0.25. And then baru masukkan dalam this equation. Okay, so later saya akan go on lagi sekali. Kalau macam saya ada buat salah nanti saya akan update. Okay, and then last one, last question. Okay, which of the following pairs of solutions when mixed would give a neutral solution? Ah. How would we know? Wait a minute, sorry, I end the question, saya nak tengok the answer. Patut bagi soalan yang saya buat je, senang. This would give a neutral solution. Option number 2, 100 centimeter cubic of 1 mole. Okay, later saya akan check. Never mind. Okay, apologies for this confusion. Kita take 5 dulu dan kita akan sambung in 5 minutes.
A titration is a technique used to work out the concentration of an unknown solution when you know the concentration of another solution. You carefully add the known solution to a set volume of the unknown solution until the reaction is complete. This enables you to work out the concentration of the unknown solution. You may need to use an indicator to signal the end of the reaction. You can calculate the concentration of an acid or an alkali by carrying out a titration experiment. In this video, we are going to look at how to carry out titrations. In the next video, we will then look at the calculations to go with the experiment. The apparatus needed for titrations looks like this. The pipette is used to accurately measure a certain volume of the unknown solution into the flask. The burette is then used to accurately measure and add the known reactant to the unknown until the reaction is complete. The burette can measure up to a 0.05 cubic centimeter accuracy. To carry out a titration, you follow these steps. 1. Using the pipette, add a set volume of the unknown solution to a clean conical flask. 2. You may also need to add a few drops of indicator. 3. Fill the burette with the known solution and make sure it is leveled off at exactly 0. 4. Slowly add the solution from the burette to the unknown solution in the conical flask. 5. You may need to swirl the flask to mix or use a stir plate. 6. Stop adding when the reaction is complete or the endpoint is reached. This is where an indicator may help you because there would be an appropriate color change. 7. Record the final volume on the burette. This gives you the volume of the solution added. This volume is called the titer. 8. For an accurate experiment, you should repeat this experiment a few times until you get consistent values for the titer. Depending on the indicator you use, the color change will be either gradual or sudden. If you are carrying out an acid-alkali titration, you may use universal indicator, which would give a gradual color change. Though this might not be ideal because of this gradual color change. Litmus gives a sudden color change. But there are other better indicators that are specialized for the acids and the alkalis in the titration. Sometimes the acid may be the known solution and the alkali unknown, and other times the alkali the known and the acid the unknown. So we have carried out the titration a few times and have a consistent value for the titer. What do we do next? Titration calculations. Now that you know how to carry out titrations, watch the second part of this video to see how to do titration calculations, to work out the actual concentration of the unknown solution. All you need to
Okay, so that is how we perform a titration. I share it again because it's kita akan masuk a new chapter into chemical analysis. Okay, so in this chemical analysis kita akan go in detail lagi. What are the types of chemical analysis that we perform in labs to determine certain values lah of pharmaceutical drugs in analysis. Okay, so kita ada dua analysis kat sini. Kita ada titration. Titration ada 4 jenis, 4 types, and the other one is gravimetric analysis. Okay, so these are the two chemical analysis, titration and gravimetric analysis. Dalam this chapter kita akan tengok the types of titrations and gravimetric analysis. The goal of this, by the end of this chapter, you should be able to do all these 3 things. Kamu boleh bezakan all the different types of titration, understand how each of the titration works, what mechanism work the titration, and lastly identify the purpose of all these different types of analysis. Selalunya kita tengok the application lah. Acid-base titration is best used on analysis for which kind of substance. Redox titration is best used for what? Yeah?
Sir,
Yeah?
sir ada present slide ke?
Astaga. Yes. Sorry. Thank
Okay.
you.
Okay.
Share my entire screen. Wait a minute. Stop. Let's share. Because kalau saya share screen the whole thing. Okay. So ini yang saya contoh tadi. This is the lecture note yang saya upload dalam Google Classroom, so everyone can have this. Kita akan tengok two types of chemical analysis kat sini. Titration. Titrations pula ada 4 jenis. And the second chemical analysis adalah gravimetry analysis. These are the outcome of this chapter. Yes, differentiate the types of titration, understand how everything works, and identify the applications of all the analysis. So before we go into in detail, titration ataupun titration is another word that we use to describe this analysis. So there are 4 types of titration ataupun titration analysis. We have acid and base. We have gone into this a bit dalam chapter 2. Ada redox titration, precipitation, and complexometry. Tapi in this module, in this syllabus, kita akan tengok the first 3 sahaja. This one, and this one. This one saya leave out. Okay, this, just like the name implies, it's a bit complex. And students always have trouble understanding it. So I think it's better if we just leave this out for a while. And these 3 are the most commonly used anyway. Okay, complexometric, a bit digunakan juga, tapi not as wide as these 3. So I think it's okay if we just omit this last one and just focus on the first. Okay. So let's take a look into the first one, acid-base titration. So hari ini kita akan habiskan acid-base titration dulu. Lagi 2, redox and precipitation kita akan tengok hari Jumaat. Okay, so acid-base titration adalah a reaction between acids and bases, and they are known as neutralization reaction because bila kita biarkan acid bertindak balas dengan base, they will neutralize each other. Okay, so neutral in this case mean referring to the pH scale, pH 1 until 14. And this is 7, neutral. So if you remember, 1 until 6 is the pH scale untuk acid. 8 until 14 is for alkali. Wait a minute, I have no, cannot touch. Okay, no, don't keep them up. Okay, so neutralize in this case meaning kalau kita biarkan acid dan base bertindak balas antara satu sama lain, pH acid ni akan naik moving towards 7 and alkali akan turun moving towards 7. So that's why it is called a neutralization reaction. Okay, and acid-base titration, there are 3 types. There are three things that you should know about acid-base titration. One is what is acidimetric, what is alkalimetric, and what is non-aqueous titration. Okay, so let's take a look at acidimetry and alkalimetry. So what are they? So acidimetry and alkalimetry is just a fancy term. Okay, a fancy term untuk bagi tahu kita tengah buat apa. So for example, acidimetry. Acidimetry is talking about the determination of acidic solution concentration. Kalau kita titrate dengan base. Okay, so katakanlah you have a solution here. This is a conical flask and this is acid. Kamu tak tahu concentration dia. So kamu titrate dia dengan a basic solution. That means you are performing acidimetry. Alkalimetry is the other way around. Kalau kamu titrate a basic solution using a acid standard solution, that means you are performing alkalimetry. So acidimetry and alkalimetry is just a term that we use to describe what we are doing, what concentration, what types of solution that we are trying to determine the concentration of. Okay, so dia bukan, it's not like a technical term. Just a way, a term that we use to describe what we are, what kind of titration we are performing. Nak cari concentration acid ke, nak cari concentration base. Okay. So this one kita dah have gone through in chapter 2. Stoichiometry, acidimetry, equivalence point and endpoint. So the thing is, tadi dalam soalan in the quizzes tadi, saya ada satu soalan yang dia betul tapi saya salah. Okay, iaitu soalan dia tanya endpoint dengan equivalence point. Dia tanya adakah endpoint dan equivalence point occur at the same time. Endpoint. Point dan equivalence point. Okay, so jawapan yang betul adalah it does not happen at the same time. Okay, so what happens first adalah the equivalence point. Okay, bila kita titrate the equivalent amount of acid and the equivalent amount of base will react together sampai complete dulu. Tetapi our indicator tak detect lagi. So this is because indicator tu hanya akan detect the type of solution yang dia react with. So for example, let me explain myself. Kalau contohlah kalau kita guna indicator phenolphthalein. Okay, so phenolphthalein ni, this is an indicator solution. Kalau kita masukkan dia dalam an acid solution, the color dia will be clear. Okay, the color will be clear. Tapi kalau kita masukkan dia dalam a basic solution, color dia akan jadi pink. Okay, so kalaulah kita titrate, kalau kita titrate a basic solution, katakanlah in this conical flask, we have a base solution. Kita nak cari dia punya concentration. Kita titrate dia dengan acid. Okay, so the problem is bila kita titrate ni, kita masukkan indicator. Sorry, saya dah cakap. Kalau kita ada acid kat sini, okay, before we begin this titration of this acid, kita akan masukkan phenolphthalein dulu. A few drops of phenolphthalein. Tapi the color will not change. Okay, because phenolphthalein in acid, the color is still clear. But as we titrate this acid solution with base, kita akan add sedikit demi sedikit into this acid solution. So lama kelamaan, this acid akan jadi neutral. Tetapi this phenolphthalein tak akan tukar warna lagi. Because kalau dalam neutral solution, phenolphthalein is still clear. Tapi kita titrate sikit lagi, just a few drops, 1 ataupun 2 drops. This neutral, kita jadi neutral. Selepas neutral, dia akan go past neutral, dia akan jadi base. Dia akan jadi base. So just turn into a very big base. Barulah this phenolphthalein akan react with the base, dia tukar warna jadi very light pink. So kalau dia dah jadi neutral, this is the point yang kita kenali sebagai equivalence. point. Tapi the end point belum lagi terjadi, because the end point akan terjadi bila dia terjadi very weak base. So kita dah nampak, because phenolphthalein dia tidak balas with the very weak base and the color that terjadi very pale pink. So dalam that previous quiz just now, he was right lah, the end point does not occur at the same time as the equivalence point. Technical kat sini, because ini contohnya betul lagi kamu kenapa. Okay, so all these things that I've gone through dalam chapter 2. So acid base titration, so these are all the M1V1 equals to M2V2. Oh, that's right. Tadi this is the lecture note yang saya mention, saya refer to just now. So this is the table yang saya maksudkan bila saya cakap ada indicator yang kita gunakan according to the strength of the solution. So kalau kita titrate, ya,
Yang tadi tu kan, yang phenol tu,
yang apa?
yang phenol ni.
Phenolphthalein. Phenol tu lain.
Oh,
Kenapa ganda?
tadi sekata itu weak kan? Dalam quizzes.
Sekejap, saya tak faham soalan kamu. Saya boleh ulang lagi?
Phenol tadi tu dekat quizzes buat weak.
Saya tak ingat kamu masukkan mana satu ni. Kamu kena ulang the full thing. Saya tak ingat.
Oh,
Soalan Najiah tu macam ni sir. Dekat soalan quizzes tadi ada soalan yang phenolphthalein is a weak base, macam tu lah soalan dia. Tapi jawapan dia true. Tapi dekat kotak bawah tadi dua-dua strong.
No. Ada weak dekat sini. Strong dengan weak. Strong, weak, strong.
Tapi itu bukan untuk methyl orange or methyl red ke sir?
Kalau kat atas ni phenolphthalein. So kat atas ni kalau dia bagi tadi, let me draw. Okay, so apa nama dalam soalan, now I remember. Soalan dalam quizzes tadi tu, dia bagi kalau dia titrate dengan weak acid dengan dengan strong base. Strong base. Okay, so ada lagi satu dia tanya dalam soalan tadi, pernah saya tulis tepi ni. Okay, dekat atas lah. Okay, satu lagi dengan strong acid. No, tak ada dekat sini, dekat atas. Okay, so kat atas ni is strong acid. H2SO4 is strong acid. Okay, so dengan weak base. This is weak base. Sorry lah, apologies for the writing. So kalau dalam soalan quizzes tadi, saya tak ingat macam mana dia punya susunan. So I just remember I can show you from my lecture note here. Kalau strong acid dengan weak base, better guna methyl orange ataupun methyl red. Kalau weak acid dengan strong base, better guna phenolphthalein. Okay, saya tak ingat exactly soalan dalam quizzes tadi, but this is yang ada dalam my lecture note lah. Tapi ini saya tak include, because kalau dah sini acid dengan base, kalau strong acid dengan weak base, methyl orange. So kalau terbalik, kita guna phenolphthalein, the other way around. Okay, so kenapa? Let me explain kenapa kita guna ada specific indicator kalau we are dealing with the weak counterpart. Okay, so contohnya kalau macam kat atas ni, strong acid dengan strong base. So kita boleh guna either one. Okay, tapi kalau strong acid dengan weak base, they recommend just methyl orange ataupun methyl red. So this is because this one of this solution will only be efficient with a stronger counterpart. Okay, contohnya phenolphthalein. Tadi lah example tadi saya kata phenolphthalein kalau kita campur dalam acid, the color is clear. Tapi kalau kita campur dalam basic solution, the color is pink. So this is because phenolphthalein reacts better with base. So that's why there's a color change. Okay, the reaction is more efficient. Tapi dalam acid, not so much. So that's why dia tak detect. Dia tak berlaku, there's no reaction. Kita add dalam acid. Okay, so kalau kita gunakan both counterparts, both reagents are strong, kita boleh guna either one. Okay, because both are efficient kalau dua-duanya strong. Tetapi kalau one of them is weak, kalau contohnya kalau weak base. Kalau weak base, kita tak boleh nak guna phenolphthalein because this phenolphthalein is efficient, is best used kalau the base is strong. Tetapi kalau the acid yang strong in this case, that's why they recommend guna methyl orange because methyl orange akan ada reaction with acid but not in base. Okay, so the same goes untuk methyl orange lah. Kalau kita add dalam base, no change, no color. Dia other way around, dia terbalik. Tapi kalau kita add dalam acid, dia akan bertukar warna jadi red. Okay, dia terbalik. So that's why they recommend kalau ada a strong acid, tapi kita titrate dengan a weak base, guna methyl orange. Tapi kalau kita titrate a weak acid dengan strong base, guna phenolphthalein. Because phenolphthalein react dengan strong base, methyl orange react dengan strong acid. Okay, so clear bahagian ni?
Clear, sir.
Okay, so apologies again for the cantik-cantik. Okay, so these are the three indicator lah, methyl orange, methyl red, ataupun phenolphthalein. And we use a specific indicator solution depending on the strength of the acid ataupun the strength of the base. Okay, moving on, kita nak tengok non-aqueous titration. So what is non-aqueous titration? It's still acid and base, tapi we are dealing with a very weak base and a very weak acid. So let's take a look at the definition of non-aqueous in the rule. So what is aqueous? It's something that contains water ataupun very watery. Okay, because in lab, in makmal, kalau kamu masuk dalam mana-mana makmal, kalau kamu nak prepare any solution, if you want to test certain chemicals, certain drugs, pharmaceutical drugs, I mean, kalau dia datang dalam bentuk tablet, you have to grind the tablet and then mix it with a solvent and then you make a solution. You have to turn everything into solution first, baru boleh perform any kind of analysis. And most of the time kita akan guna water as solvent, okay, because most things akan dissolve, akan larut dalam air. Okay, tetapi sometimes water ni dia boleh interfere dalam certain reactions, dia boleh mengganggu. Okay, so that's why saya tunjuk kat sini dalam why do we do this ni. Water can interfere in the reaction. So bila kita titrate certain substances using water, kita akan dapat inaccurate endpoint ataupun inaccurate equivalence point. So that's the problem lah. Kalau kita tak dapat accurate endpoint, kita tak boleh buat, tak boleh determine the accurate amount of concentration. So that's a very big no-no. Okay, so that is the problem. Kita dah establish the problem kalau kita titrate menggunakan air if you are using a weak acid ataupun weak base. Water could interfere. Okay, so why can water interfere? Saya nak kamu revisit your first year. Water can behave both as acid and base. Okay, the definition of Bronsted and Lowry, water, any substance that donates proton, dia adalah acid. Any substance that can accept proton, dia adalah base. Okay, so this is the definition of an acid and definition of a base. So H2O in this chemical equation, bila dia dissociate, dia akan pecah menjadi H plus dan OH. So this H plus ni is available to be given to any chemical substance yang lain. So dia boleh donate this H plus. And also dia ada OH minus kat sini. And also dia boleh accept any H plus. Dia boleh hasilkan hydronium ion, H3O plus. So they also can behave as a base. So in an acid-base titration, if this water is the stronger base, or if this water is the stronger acid, dia boleh interfere with the titration. So for example, kat sini saya tunjuk an interference of water dalam kalau kita titrate a weak base. So if you pay attention to the chemical equation dekat belah kanan ni, so this is ammonium hydroxide, this is a weak base. So kalau kamu masuk dalam lab, kamu timbang katakanlah okay, 10 mg of ammonium hydroxide and then you dissolve in 100 ml of water. Okay, you dissolve. This is the water you dissolve it with. Okay, and this water, as we have established tadi, dia boleh behave as a base. So kalau this is a stronger base than this one, ammonium hydroxide will not react dengan our standard solution, acid ni, strong acid. So instead, water yang akan bertindak balas. So if you take a look at this chemical reaction, in the end, ammonium hydroxide tidak bertindak balas pun. So dia punya chemical formula NH4OH, in the end dia masih lagi NH4OH. None of the atoms are used in the reaction, but instead water pada asalnya dia adalah H2O, tapi in the end dia jadi H3O+. And HCl jadi Cl- because dia dah donate dia punya hydrogen to water. So the reaction is not between HCl dan juga ammonium hydroxide as we wanted, tetapi between water dan juga HCl. Because water telah mengganggu. So just imagine water ni macam a third party. So in a relationship, katakanlah macam ada another party join in, orang ketiga lah. Okay, that's how I understood it. So instead of these two bertindak balas, H2O akan come in the middle and dia akan bertindak balas instead. So ammonium hydroxide does not change. So the end point that we get kalau kita titrate this is not the end point of ammonium hydroxide. Kita nak cari concentration ammonium hydroxide ni. Tapi kita akan dapat end point, but that's not the end point of ammonium hydroxide. That's not the equivalence point of ammonium hydroxide dengan HCl, but the equivalence point of water dengan HCl. Okay, so the same goes kalau kita titrate dengan weak acid. Kat sini saya pilih contoh formic acid, a very weak acid. Kalau masuk dalam lab, kita prepare with water. So instead of this reacting with the strong base, this is a strong base, our standard solution, water yang akan bertindak balas. Dia akan behave as a stronger acid than this formic acid. So in the end, dia punya none of the atoms in formic acid changes. Dia masih lagi HCOOH. Okay, tapi yang bertindak balas adalah water dan NaOH, sodium hydroxide. So they interfere with the reaction. So we do not want this. And this is the problem kalau kita titrate a weak acid dengan a strong base. Namun juga kalau kita titrate a strong, sorry kembali. This is a kalau kita titrate a weak acid dengan strong base, this is the problem. Okay? Kalau kita titrate a weak base dengan strong acid, also this is the problem. Water could interfere. Okay, air boleh mengganggu. So that's why kita gunakan a different kind of solvent. Kita tak guna air. So what are the types of solvent that we could use? Dia dibagikan kepada 4 jenis. Aprotic, protogenic, protophilic, and amphiprotic. So untuk aprotic solvent, contoh kat sini saya bagi chloroform dengan benzene. So these solvents, chloroform dan benzene, they are chemically inert, meaning they are stable and tidak mudah bertindak balas dengan strong acid ataupun strong base. So if you want to titrate weak base ataupun weak acid, kamu boleh guna chloroform ataupun benzene. So they are known as aprotic solvent. The second one adalah, as soon as I can get it moving. Okay. The second one adalah protogenic solvent. So these are acidic substance that yield proton. So kalau kamu ada a weak base, kamu nak titrate a weak base dengan a strong acid. So kamu boleh guna these two. Sulfuric acid ke, HCl ke, nitric acid. Kamu timbang this weak base, dissolve dalam sulfuric acid. You can titrate lah dengan your standard solution. Okay, so these things tidak akan bertindak balas. So kalau kamu nak titrate dengan a strong acid, the solvent that we use is also acid. So dia tidak akan bertindak balas dengan acid. So strong acid akan bertindak balas dengan base. Okay, so that's why kita boleh guna protogenic solvents macam sulfuric acid, hydrochloric acid ataupun nitric acid kalau kita nak titrate with base. Kalau kamu nak titrate with acid, jangan guna protogenic solvent. Okay, next adalah protophilic solvent. This is the opposite of the last one. Kalau kamu nak titrate a weak acid. Kalau kamu nak titrate a weak acid dengan strong base, so kamu boleh guna protophilic solvent. Contohnya macam amides ataupun and lastly, amphiprotic solvents seperti acetic acid, GAA, glacial acetic acid dan juga alcohol. So amphiprotic solvents meaning they boleh behave as both acid dan juga. So this oxygen part here dalam glacial acetic acid ni, dia boleh accept proton. So any substance by definition if they can accept proton, dia adalah base, and also dia ada hydrogen here to be given away, and any substance that can donate proton, dia adalah acid. So that's why amphiprotic solvent is something that can behave as both acidic and juga basic. Okay, so indicators also differ lah. Kalau kita nak titrate different things, kalau kita nak titrate base, kita gunakan crystal violet. Okay, before we begin the titration, kita akan masukkan a few drops of crystal violet dalam the solution, the basic solution. So the color will change to violet, and our goal is to get neutral color. So kita nak titrate sampai blue-green sahaja. If we went past the blue-green dah jadi yellow, that means kita dah way past the equivalence point. So in this case, kita boleh dapat the equivalence point and the end point at the same time. Okay, because the punya color change is different. Kalau basic solution, warna dia violet kalau kita guna crystal violet. Tapi kalau dia dah titrate dengan acid sampai jadi neutral, warna dia akan jadi blue-green. Tapi kalau kita terlebih titrate, if we over titrate, dah jadi acid, the color will become yellowish green. So we know kita dah terlebih titrate. So tak accurate lah our concentration calculation kalau kita ambil this value here. So the same thing applies untuk different indicator, alpha, naphtha, benzene, orange, blue, and quinolide red. Okay, so pay attention to the color changes. Untuk quinolide red and the last one ni, the punya color change to neutral tidak ada. Dia akan remain magenta sampailah almost colorless. So kat sini, in this case, the endpoint and the equivalence point are not the same. Equivalence point adalah when the solution has become neutral. Okay, so kalau equivalence point and the endpoint is the same, that means the pH is neutral. And lastly, the applications. Kita guna acid-base titration of non-aqueous titration ni untuk ubat-ubat apa. So kalau kita the API of the drug, okay, the active ingredient of the drug adalah a very weak base. It may need a very weak base, especially secondary and tertiary. So kalau dia punya API adalah weak base, macam mana nak tahu API itu weak ke strong base? Kamu tengok pharmacopoeia. Okay, so contohnya macam tablet adrenaline, caffeine tablets, protein phosphate, diazepam. So the best way to analyze these drugs adalah dengan menggunakan non-aqueous titration. Kalau the API is weak acid, weak acid macam contohnya chlorpromazine hydrochloride, ephedrine, fenformin dan propanolol, kita boleh guna non-aqueous titration juga. So use the indicators, solvent yang ditulis dan kita tengok tadi. Okay, so that's it untuk acid-base titration. So untuk acid-base titration ni saya nak kamu faham how does it work? And how does acid-base titration work adalah dengan the reagents neutralizing each other. The equivalence point is the point at which both substances have become neutral, and the end point is the point where the base has turned into a little bit acidic and the acid has turned into a little bit basic. Okay, itu perbezaan dia tadi. And saya juga nak kamu faham what is non-aqueous titration. Okay, identify, understand what it is, and understand the need for non-aqueous titration, and understand the interference of water, and lastly the application. Okay, so that's it untuk non-aqueous, acid-base non-aqueous titration. Do you have any questions? Apologies lah kalau serabut sikit saya punya writing ni, because I'm still looking for the best app untuk guna this writing pad. Saya tak sure sebab internet problem ke dia affect my laptop, because pagi tadi saya guna untuk kelas yang kecil, ada just 6 students, no problem. Tapi bila jadi ramai-ramai macam kelas kamu ni, dia lag, dia lambat detect movement of my stylus. Okay, so kalau tidak ada soalan, kita jumpa hari Jumaat nanti to continue the second part of chapter 3. Kita akan habiskan redox and precipitation titration. You could watch the videos first yang ada dalam Google Classroom. That reminds me, saya dah post sebelum? I haven't posted. Okay, so lesson 8 and 9. Tak silap saya akan post later today. Jadi after class. Okay, and also saya nak ulang lagi sekali kamu punya lab class, physical lab class. I was told pagi tadi tapi saya tak sempat go into detail lagi. Pada asalnya kami plan to do on the week of 4th October. Tapi saya tahu pagi tadi cohort 35 will come a little bit later. So cohort 36 akan buat lab class with cohort 34. Cohort 35 buat a week after 34 and 36. And yang tak datang ke lab, kamu kena join the class secara online. I will live stream the class. Saya tak sure lagi nak guna YouTube ataupun Instagram live ataupun Google Meet. Saya tak test lagi which one is better. Punya fee. Saya kena test dulu, nanti saya update lah. Tapi kalau tak boleh, if all else fail, Google Meet. Because so far we have been using Google Meet. Saya cuma nak bagi orang kat rumah nampak clearly macam mana kerja-kerja kat lab tu buat macam mana. So kalau saya nak guna my phone, better use Instagram live so that I can move the phone around. Okay, so we will update you guys about the details on how we are going to do the lab class later after saya dah finalize all the schedule. Kalau ada soalan, nantilah kita akan update dan adjust everything. Okay, so kalau tak ada apa-apa lagi, make sure you sign into today's attendance. See you guys on Friday. Bye-bye.
Thank you, sir.
Thank you all.
Thank you, sir.
Thank you.